prefer you learn the theory concepts. The reason is, uh, if you go more into the coding concepts, you may not be able to understand it properly, because unless you do the previous ones, whatever is explained up to 8th, 9th unit, all those things has to be done to get more advanced versions. 9, 10, 11, 12 are the no 10, 11, 12 are advanced Python concepts. In the advanced Python concepts, completely almost like a backend how the things are working, or the classes or objects. All these concepts are there in the 10, 11, 12 concepts. So, programming, what can come in the exam is up to ninth, you can prepare. A few loops and the other things you can work on. Whereas regarding the concepts in this part, you can learn the summary or the introduction part of it. I'll just explain you quick what is this, because today is going to be the last day. Just a second. So, let's see what is in the chapter. This is completely advanced concepts of Python. First one is called the object-oriented concepts. Object-oriented concepts, we have classes, we have objects, we have methods, member variables in Python, inheritance, static methods, interfaces, private members, etc. So what are object-oriented concepts? Object-oriented concepts means whatever programming we are writing, we are working towards. Suppose I'm preparing a list. List is towards one particular object of creating students' details or creating an employee's details, something I'm working on. So there is an object and then I'm working towards that object. So here we understand the object-oriented concepts. What are object-oriented concepts? Object refers to a particular instance of a class where the object can be the combination of variables, functions, and data structures. Combination of variables. See, for example, if I take our class, BCom Computer Applications. So BCom Computer Applications, if I take our class has some different subjects, different concepts, different combinations of subjects, units in that, concepts are different. And the Python what we are learning need not be the same Python what BSc people are learning or BBA people are learning. It's all different. It is separately a class in itself. So this is called an object. Our BCom computer applications can be called as an object, because here the students' parents details, their previous marks, their present marks, or the next semesters up to 6 semesters, what are their marks that are coming. All these are nothing but the variables and the functions and the data structures. So when we put all as one combination of the things, then we call it as an object. So a good understanding of the OOPS concept can help in decision making when designing an application. Now in the bigger companies and bigger concepts, we will have not one class or one concept. We can have bigger things where decision making should be taken. Suppose for a college or for a university, a decision has to be taken. So combination of all the classes or combination of what is the prime goal of this program running. So they will take the decision taking will become very easy when they talk about the OOPS concept. Then object-oriented programming is the programming style which is associated with the concept like class, object, inheritance, encapsulation, abstraction, and polymorphism. Class is, you understood what is a class now. Object is there is a content, there are variables in that, there are lists in that, there are data structures in that. So all those things contribute to the object. Then inheritance. Now, is it the first time that is happening? No, there are previous classes also that took place. There are become computer applications second semester last year also took place for some other students, for some other things. So there is some inheritance that has been done. It's not the first time it is starting, right? So there is an inheritance from the parent group. We are inheriting. Suppose, for example, the roll numbers, the hall ticket numbers, what we got, it is 20. Let us think your batch is 2022 batch. So 2022 batch and 21 batch, 20 batch, 19 batch. So there is an inheritance from 19 to 20, 20 to 21, 21 to 22. Inheritance in the concepts, or in the concepts, inheritance in the aspect of teaching, inheritance in the aspect of conducting the examination. Several concepts will be there. So all those things are inheritance. Encapsulation. Whatever we do now, after doing it, we just go through that whether we did it perfectly or not. So those are called encapsulation. Rechecking the whole thing and ensuring that we are taking a proper decision. Abstraction and polymorphism. Abstraction and polymorphism also in the same manner they work. Once there are attributes that belong to the class, you can define functions that will assess the class attributes. So you have an object and you have done all those things, inheritance and extra, all those things, if you have worked out, then we can call the functions and then start assigning the functions to the objects. So this is completely called object-oriented programming. You can also provide the values. Sorry. Yes. You can also provide values for the attributes at runtime. So now, for example, our class is there, our class attributes are there. So at this attributes, I have created a new nodes, I've created a run at the runtime, I've created something. So this new attribute is inside the method. Now this in whatever is inside the method, this method can be again called back and can be refreshed again and can be used again in the next classes also. So a class creates a new local namespace where all the attributes are defined. In this particular class, whatever attributes are defined, these attributes in the local data, it is stored and then it is stored at the back end so that it, whenever we want to call back, all those details, attributes can be called and then worked on it. For example, a doc underscore gives the document string of the class. I say Harshit Patil. So Harshit Patil, name of the student, name underscore student. So student name I want to have, name of the student underscore underscore I put, and then I will write every time name of the student to write. It is a class. So all the students' name, Manjula or Priyanka or Kranti, like that, all the names I can enter into that, becomes a class. For this class, I'm putting the attributes. You're all some certain age, you're all studying BCom, something like that. I can create the attributes. Now, these attributes are created at the runtime. I mean, now, presently. So this thing, is it the first time your hall ticket numbers are generated? No, they are already generated previously. Their hall ticket numbers are there, but there is a code, there is a standard way of working on, from which university, from which center, from which year, what group. For generally, this is how the roll numbers are given. For example, if I say in general, Usmania University, the number goes like this: 2014, 405, then 003. Let us think how this number can be read out. So first, actually, if you see, this number looks so different and so difficult to remember. So if you, I will bifurcate this part like this. I'll bifurcate, and if you see now, 2014 is the is the college code. College will have a code, right? So it is the college code. 20 is the year, in which year you got yourself registered. Suppose, for example, you have registered now in 2022. So 2022 is the registration. Then 405 is your computer applications code, and 003 is actually your ID number. So this is how the attributes are being generated, and then some part inherited and some part is generated. So this 003 is the new attribute that is assigned to, let us think it is Harshit Patel. So to Harshit Patel, 003 has been assigned. It's a runtime assignment. Whereas the inheritance is already this code, college code is there, year code is there, and course code is there. All are already there. So if you take like this is a simple example what I gave, but this kind of examples can be there plenty. So this class object allows us to access different attributes as well as to instantiate a new objects of the class. See, this is 003 is a new object or new attribute what I have given to the class. So that is given all the time whenever you are creating at the runtime. And that remains again back, it goes back and then it becomes as an allocation for a particular student at the back end, right? That will not be erased again. So same manner, when you see classes provide a means of bundling data and functionality together. It's not only creating data, but any functionality I want to check, the results I want to check, or the what notes I have to check, what assignments has to be given, everything. This is only with respect to the classes I'm still telling. In the businesses or in the big programs, how this classes are taken care of. So the new attributes, whatever we are working on, the classes takes them, and it is not only bundling the data or putting all the data at one place, but it is defining the functionalities of the classes. Functionalities means how it has to work. All those things also will be defined. So creating a new class creates new type of object, allowing new instances of that type to be made. So it always allows to create new things. When you create new things, new functionalities, new aspects, then what will happen? This gets added to the previous ones and then it gets stored back. So your backend, the data set is increasing. At the same time, new functionalities, new aspects are getting added to the previous one, right? That is how the object will be functioning. Each class instance can have attributes attached to it for maintaining its state. Class instances can also have methods for modifying its states. If you want to modify, okay, this is not appropriate, this chapter we have to revise, or this chapter, this lesson has to be modified a little more. Whatever we want to do, all those things can be done in the functionalities aspect whenever we want to bring out the changes. Compared with other programming languages, Python class mechanism adds classes with a minimum of new syntax and semantics. Semantics is just like in English, there are semantics. You write first letter with capital letter, remaining small letter, and then there is a space after each object. There are punctuations, there are certain things. So semantics will be there. That we have to check on that. So Python allows to do all those things in with minimum syntax. Of course, Python is so comfortable. Its syntax is so minimum that it is easily to be written, right? Then Python classes provide all standard features of object-oriented programming. We have classes, inheritance, and attributes. All those things is Python allows. And remember one more small thing, whenever we override means already one class is created, one set of attributes are created, and in the runtime, I have modified it and then I have improvised that attribute or functionality, then what will happen? The old thing is erased and the new thing will go and then sit in that place. Then the next time when I open the system and start working, the new thing only will open, but not the old. That is where it works on. Objects can contain arbitrary huge quantities of data. As it is, as is true for modules, classes partake the dynamic nature of Python. They created a runtime and can be modified further after the creation. Once you create it, it is not that it is end. You can keep modifying at the runtime, and then whatever you are modifying, that gets added and then it gets stored into the systems. Methods may reference global names in the same way as ordinary functions. Global scope associated with method is the module containing its definition. So whatever you are defining the class, the object what you are defining, it understands the object, and then the module whatever definition we are giving, it takes the definition and the functionalities and start working on it. So Python classes are really very, very important. And in future, that in basic classes, you can start learning them as advanced techniques of Python programming. Usually class contains the method is itself defined in the global space. In the next section, okay, this all is not necessary. Execution of a derived class definition proceeds the same as the base class. Whatever new class we have created, actually it works on the basis of the previous class only. So base class, it takes the parent class, you can call. I created one class, and then from there I'm taking the inheritance. I will show you one inheritance concept. One second. So here, this is the object data. Student add student member function. Class student data, admission number, name, father name, date of birth, gender, address, course. These are all the data. Now member functions. What are the functions? I can add student or update student, student information I can update, delete student. Some students drop out, so I can delete students, I can print the students, I can do any kind of functionalities for the student. Then but in the university, let us think that it is a university data structure, data mode. So in the university, it is not only one become class student. Like that, n number of classes can be there. Like that, n number of courses that can be running. So for all that, we have to take the data. And whatever we are running, the examinations or the results and other things, all that is done on the whole data set or on all the objects. The functionality is what we do is on all the objects that takes place. So member functions, add table and update table, delete table, print table. These are all the functionalities. Then instance, an individual object of a certain class, an object John that belongs to a class, student, for example, whether they belong or not belong, all those things can be told. This type of things you have already learned in the previous classes. The behavior of John object, all the details of John, etc. Then encapsulation. Okay, this is more important. These three: encapsulation, abstraction, and interface. This is the process of wrapping data members and methods into one entity, which is called as a class. Encapsulation. Once I created it, is not end. I created it. Is it appropriate or not? Is it sufficient or not? Is it enough? So that I can create a model out of it. So all those things, wrapping data and methods into one entity gives the flexibility such that when we create the class or object, both the data and member functions will be instantiated for that object. If once I create BCom computer applications class, so this is created once permanently, and then the functionalities are defined, the members of the class are defined. So if once we create everything, then I'm rechecking whether everything is properly done or not, is called encapsulation. Then abstraction means showcasing only the required things to the outside world while hiding the details. Suppose I want to show that how the class is performing, I can take the class average and show than showing each individual student's marks. Probably some students might have got very less marks, which I don't want to show because they belong to the class. So I don't want to show some information. So if you don't want to show, I don't need to show your Aadhaar card number. I don't need to show your hall ticket number. So some of the information can be hidden, and I can show only those attributes whichever I want to show to the outside world. So that way we can create the object, create all the information, but abstraction helps us not to show everything to the outside world. The concept of abstraction focuses on what an object does instead of how an object is represented or how it works. You don't need to show everyone how you are getting it. What everyone wants to know from you, it is only how many marks you got it. That's it. So how it works, that's it. Not beyond how the class is working. Interface is a container which contains some common prototype functions that can be implemented by the class whenever a situation is created. So whenever you are creating a situation, it is a prototype. Based on that prototype, it will create a class and the features. Right? Start underscore engine. This is a function. So engine started or not started, or running or not running, all those details it will give. Right? Inheritance. It is a feature of object-oriented programming that allows code reusability. When a class includes property of another class. I told you from a parent, we inherit. We inherit what? The qualities of the parent. We inherit the attributes of the parent. So like that in the program also, class or objects, they inherit from the parent, from wherever you have derived. So inheritance is one important aspect because you don't need to create each and everything afresh. Afresh means first time, as if it is done for the first time. So university does not create every time to the scratch new modules, new data sets, and all. What is already there, it gets updated. Are you getting me? It gets updated than creating everything from the beginning, from scratch. We don't do that. Right? Add, update, print, student, employee, classes. All these things are can be done in the inheritance. You can update it. Polymorphism, I can create exactly the same copy, save as, copy as, like that. So that is called polymorphism. So this type of things, if you write in the exam, that should be more than enough for you for this class. Okay, I will show you one second. I'll share the notes because we have very less time to complete portion. Unit 11 is about the graphic user interface. Graphic user interface means I can in my this thing how graphic pictures or some images or text messages or text boxes. Did you create a Google form anytime? If you create a Google form, you will understand there are radio buttons, multiple choice questions, fill in the blanks or short answers. So something like that, you can create it in the Python program also. So that kind of a graphic user interface will help us to do all those things. More widgets or callables, binding packages, widgets, etc. Let's see what it is. Uh, Here they are introducing the Python program Tinker. T, you can see this Tinter. Tinter, you can call, is a Python binding to the TKGUI toolkit. This is very advanced concept. What you do is only learn the concept because that is, we have to download more libraries and work on it. So TK is the original GUI library for Tell language. So this is all very important. Each one, I will send you the notes once again. So TK is the original GUI library for Tell language, TL language, actually. Tinker is implemented as Python wrapper around a complete TCL interpreted embedded Python interpreter. It is actually a built-in Python module used to create simple GUI apps. So generally we can do it without even downloading, but still we have to have this interface. Some of them may not be supporting, so we have to take them and then work on it. So both TK and Tinker, both TK and Tinker are available on most Unix platforms. Generally now, that's why I'm not showing. This is on the Unix platforms and different softwares, Macintosh systems, etc. That's why I'm unable to show them. So starting with the 8.0 release, TK offers native look and feel on all platforms. Tinker consists of a number of modules. The interface is located in a binary module named as underscore Tinker. Kinter, I can call instead of T silent, Kinter. This was Kinter in earlier versions. This module contains the low-level interface to TK and should never be used directly by the application programmers. We cannot do these things directly. It is usually shared library DLL, but might in some cases be statistically linked with the Python interpreter. In addition to the TK interface module, Kinter includes the number of Python modules. The two most important modules are Tinker module itself and TK constants. The former automatically imports the later, and so to use Tinker, all you need is to import one module called import Kinter. Okay. So in this, we can have the buttons. Yeah. We can have the buttons. Buttons means check boxes will be there, no? Like that check boxes or callbacks or canvas or widgets. Whatever this thing what I'm writing, it's called a canvas. I'll show you one module there. Creating button widget. All this. Suppose I have a screen. Let us think that my laptop screen is there. In the laptop screen is like a canvas. And on this canvas, I can have an active background. Create my background as a green color or blue color or whatever color you want. Then active foreground. Foreground color and the button is under the cursor. Then border, background, all these things are the following list of options that are available for Kinter to make your user interface more attractive. Methods of button, flash, invoke, uh, more concepts are there. It looks like this, for example. This is one example of the output. Now, once you write all this data, it will invoke this kind of output for you. So that means a message box is created. In that message box, welcome to Python, it will write, click OK if you like it. If you don't, just close it. So like that, plenty of times we keep getting this kind of messages in the downloads or in the Google sites, whenever you want to have something like that. So then canvas widget, canvas widget means the canvas is a rectangular area intended for drawing pictures or other complex layouts. So canvas means I just told you the screen where I'm going to write or read, or I can build some structures on that. So all these circles, lines, images, and other widgets, all these things can be drawn on the canvas.
Only in rectangle, ma'am.
On a rectangle, on a screen. So you can have that. These are all advanced versions which I cannot show on the Colab. That's why I had to only explain you. So canvas, master option value, and master parent. So you can have the border for that. Suppose I've created, let us say, this table itself I have created. For this table, I have created a border. Border is dark, this color. If I want color, I can in Python program, I can go and then change the color of this. I can change the border. I can increase the thickness of the border, or I can height of the dimensions I can change, focus, highlight, color. So anything, all these are the different functionalities that are there with the graphic user interface. Because when we are doing any graphical images, when I want to put, I want that to be exactly fit into the screen or fit into the window what I'm opening. So all that we have to, you should be very good at art concepts where you can really put them properly. I will explain you the concepts 1 second. More widgets, no. For this, I tell you, focus on the summary and small concepts. I'll tell you what you have to practice. That much it is enough for you to write the exam.
Classes in the online
So this is binding. Okay, binding and so on. See, when this is one canvas, can you see the canvas now? In the file, new, open, save, This is one canvas where I have created one. If I keep my cursor on new and then press on that, it will new file will open, or open the old ones, whatever is already created. So these are all the creations what we can make using the Python program. Then we can have the buttons, we can have double button, all those several concepts are there. I'll show in place method. Yeah, this is more important. So Python offers multiple options for developing GUI. Out of all the GUI methods, Kinter is the most commonly used, as I told you. The label is a Tinker widget class label. Just now I showed you that one, or a drop down box. Creating GUI using Kinter is an easy task. A label is a Kinter widget class which is used to display text or an image. You can create a text, you can write the text, you can read the text, you can create the images using that. For that, we use the module of Python 2.x, right? And 3.x also is available. There is a method known as main loop is used when you are ready for the application to run. The main loop is the infinite loop used to run the application. Wait for an event to occur and the process the event till the window is not closed. Master is the parameter used to represent the parent window. There are a number of options which are used to change the format of the buttons. Number of options can be passed as parameters separated by commas. So all these things are the concepts on the Tinkers. Sorry, I can say Kinter, not Tinker. It can be called as Kinter. T is silent. Showing warning or errors. Widgets to select the files and colors. There are also simple dialogues asking the user to enter the string, integers, or float numbers. Sometimes they ask the label or the text messages will come. You enter your mail ID, enter your passwords, that labels will be coming. So those all can be created in the GUIs. The message we get can be used to display the short messages. I just told you, when I open something, I want to download some software, or I want to download some concepts. This backend, how it works. Then they will ask one label. Like that, we can create in the program, one more program. In the Python program, we can create all these things, that labels, asking for the messages or asking the user to enter some details. All those things can be done using the widgets. This is the text may span more than one line. The text can be one line, one word, one letter, or it can be more than one line also. The text is automatically broken into lines and is justified. Justified means it will just exactly. See here, your left and the right are aligned. All the lines are aligned. It is not one here and one there. So that justification also can be done. The text is automatically broken into lines and is justified. We were ambiguous when we said that the front font of the message we get can be changed. Sometimes you want the font to be big enough, or you want them to have a better vision on that. So that can also be done. This means that we can choose arbitrarily a font for one widget, but the text of this widget will be rendered solely for this font only. If you want to change the font size or color or different name of the font, so you can do all that, but that will remain only for that widget. If you need to display the text in multiple fonts, same text should be there in multiple fonts, that also can be done. But we have to use the pack. Pack is the easiest use of three geometry managers of TK and Kinter. Instead of having to declare precisely where the wicket should appear on the display screen, we can declare the positions of the wickets with the pack of command relative to each other. Okay, I'll show you one second. A few widgets I'll show, then it will make it easy. Can you see this widget? This is called the grid. We can call it as the pack method. In the pack method, all the syntax we have to write. This is Geometry Manager organize the widgets in blocks before placing them in the parent bucket. Syntax widget dot pack off. Example 9. Let's see. From Kinter port root K. We have to input root. Frame root. If we have making a data frame dot path, bottom frame for everything. How the my widget is there and what I'm doing. Bottom frame we have to create. Then where is it? Bottom frame. Then bottom frame pack where it has to be there. Bottom this side, this side, this side. Then red button. Red for red, brown for brown, blue for blue, black for black, black button, frame, black, FG, black. It has to give black font, FG font color. Then background, root, main look. This is how the outlook looks. These things can be created in the Python program. This. And one more I'll show you. Like this. Suppose a grid. I want to create numbers 1 to 36. So to create numbers 1 to 36, what I do? I import the Kinter from this thing, root tk, b equal to 0. For range, r in range 6, up to 6 we have taken values. So for c in range 6, b equal to b plus 1. So every time, first number it will put, then plus 1 it will take, then plus 1 it will take. First, it will run 1. For 1, it will take 1 plus 1. Then 2 plus 1, 3 plus 1, 4 plus 1. Then 6 plus 1. Up to 36, it will go and then stop. If you don't give any stop message, then it will continue till infinity. Then place method, you have the place method. We get dot example if we from Kinter import all these things, then let us see the output. This is called the placement. Yes. Okay. So the last concept. Let's go to the last concept. One second. Just one minute, I'm open. The last concept is the files in the Python program, basics of files names and paths, how the path is given. Suppose I want to open a particular document. You will have a path. Where is the path? Where is it? Suppose I have stored in the documents in Ambedkar University folder, in that Python program, in that second semester, in that unit 2. Like that, if I have any path, so all those paths also has to be defined. then catching expressions in databases, pickling and pipes. So these are the two important things which you need to learn and pipes in this chapter. Then here, Python, first of all, understand that it is a great tool for processing data. Whenever we want to do really, Python is very easy comparatively to compared to the other softwares or other data analysis tools. Python is really very convenient and it is very compatible with C or Java or SQL or Access or other data sources from where you can extract the data. It is likely that any program you write will involve reading, writing, and manipulating data. Whatever you are doing, you are reading or writing or manipulating data, all these things can be done with the help of Python very easily. It is especially useful to know how to handle different file formats which store different types of data. Persistence preferred to object and process characteristics that continue to exist even after the process that create. Plenty of times what will happen is when a program is prepared, when a program is prepared, it in the runtime, whatever you are preparing the files and the other things, it will store in the storage location, which is not permanent. So it will store in the temporary file, some temporary place. But suppose, for example, let us think that I'm writing a document and this document, all of a sudden I had some important work and I left and then went off. So what I wrote in that, it is stored as long as I don't, I keep open my file. But once I close and then after some time I come back and open that, whatever I have done, it will not be stored there. It gets erased. So here, what we write or what we work on is stored in the temporary volatile random access memory. The most of the program we have seen so far are transient in the sense that they run for a short time and produce some output, but when they end, their data disappears. Most of the Python programs, whenever you are writing, as long as we click that arrow mark button and then we run the program, you remember? But all the outputs will be there. But these outputs, when I go back, when I close it and then some other time I open and then see, it will not run again. You have to make it run again to see that it runs properly or not. Then sometimes I upload some data files. So after uploading the data files, if you want to if you want to run that Python code functionalities again, but if you want to run, then it will not run unless you run from the beginning of the program. So that is where it becomes difficult.
Unit, huh? This is the last unit.
This is the last, yes.
Okay.
Yeah. So most of the programs we have seen so far are transient. Transient means when we are working, it will be seen. It will give you the outputs. But once we close it, their memory is only for the short span. So once you close it, it gets erased. And when you want to rerun that, you have when you open it and then want to see the output, you will not be able to see the output unless you run the program once again. So if you run the program again, it starts with a clean slate. New class, we are fresh again. Last class mein bhul gaye. So new class, new again with the fresh slate. So clean slate, it will start. Other programs are persistent. They run for a long time. Some of the Python programs are very good. They run for a longer time and they don't, even if you run, if you close, if you open, nothing will happen to them. Whereas some programs are very short span and then they only run in the RAM. They keep at least some time of their data in permanent storage and if they shut down and restart, they pick up where they left off. Examples of persistent programs are operating systems, our operating systems. If I close it and then come back and open from wherever I left, it will open. There is no problem in that, which run pretty much whenever the computer is on, the web servers or anything which does not take more time and it does not allow you to wait for a longer time. One of the simplest ways for programs to maintain their data is by reading and writing text files. Plenty of times when you want to run the program once again or open an operating system, they read all the text files, all the files, programming files, whatever is there, all the files will be run once and check for any viruses or anything is there. Then they start opening, right? An alternative is to store the state of the program in the database. So let's say you have got a Python program, perhaps to manage your daily to-do list, and you want to save your application, the objects. You want to store it someplace because you don't want to lose it. It is a recurring one and you want to keep it at one place. So that kind of program, suppose it's simple an example I'm giving you. So this, I want to make a provisions list of my this thing, which I want to use it every month as a recurring path. This month I use, so next month also I will be using, next month also I'll be using. So the same list I want to run it again and again. So what will happen? The to-do list what I wrote, and you want to save your application. This should be independent. Even if I close or open the system, it should not get affected. Correct? If I close, suppose if it is in the short memory span, then once I close it, it gets erased, which I don't want to, because I want to use it next month also, that next month also, that next month also. So I don't want that data to be erased. Suppose the student details data. Student details data, shall I allow it to get erased? No, right? Whenever, as long as the sorry, as long as the university is there, all your names will be there. Even after 100 years, you go there also, your names will be there in the record. It has to be there because you are part of the university. So to accomplish that goal, you have got several options, each with advantages and disadvantages. Persistence is one concept where the program works on. Persistence means how long it can stay on your system, on your program. So persistence comes always with the advantages and disadvantages. One thing, these storage mechanisms all have in common is the data is stored independent of the objects. Data, whatever student details data, employees data, or the products data, whatever data you want to give, all those data is stored in the objects and programs that operate the data. It will never get affected because of any other updates or deletions. The benefit is that the data then becomes available as a shared resource for other applications. Whatever, if once your details are done, all your data is entered, then yours is one list. This can be used by other universities also, or can be used for any other purposes. The drawback is that allowing access to an object's data in this way violates the object-oriented principle of encapsulation, in which an object data should only be accessible through its own public interface. It is a violation, but still does happen. Python pickling support comes from pickle module and its cousin, pickle module, the pickle module. Pickle means it looks little different. The pickle module is provided to see better performance and is recommended the choice for the most of the applications. Suppose in the pickle module, since most of our examples are shown in the Python itself, let's start showing how to import pickle. I'll show one second. Persistence, yeah. Persistence is a process of storing objects, data, or information in terms of files on non-volatile memory. Non-volatile memory means hard disk or pen drive or something like that, which does not get erased. So that is called persistence. File or computer file is a chunk of logically related data or information which can be used by computer programmers. Then file object. We can have file close, file flush, file number is at, it is there or not, it will check. Next file, read line, one line also. You want to read one line, whichever line you want to read, that line also it will read. Then size hint, Then file truncate, file write lines. All these things are the attributes. File closed. But when you are closing the file, you can say file closed, mode, file name. All these things are nothing but the different file attributes. Opening file. Whenever you want to open the file, you can say open. So open a file object using the Python built-in function called open. Before you can read or write a file, you have to open the file and then start working on it. The access modes are simple. R, you write, opens a file for read only. Sometimes in the documents also it will come read only. You will not be allowed to modify or edit the program. RB opens the file for reading only in binary format. R plus opens the file for both reading and writing. The file the file pointer placed at the beginning of the file. RB plus opens a file for both reading and writing and the binary format. Then W opens the file for writing only. WB for writing in a binary mode. W plus plus for writing and reading. And then like that, concepts are there. So these are all those syntax only. So like this line numbers will be there. I want to read line 7. So it will tell read line 7. So it will read line 7. The racial discrimination practiced in South Africa. In Durban court, he was like that. It will read the whole sentence. Formatting operator. So like this is completely about the files. So any doubts you have? Any doubts you have? With this, we have completed the portion. So if you have any doubts, ask in the group only. Don't give personal messages. In the group, see, your doubt can be the doubt of others also. So whatever I clear in the group, that makes it easy for everyone to understand. So send it in the group only. It will be easy. Understand? Okay. Shall I close the lesson today? Okay. All the best, students. Do well.